geometry students, in this video we will learn how to solve right triangles and also apply this to word problems. The heading today is called Solving Right Triangles, Lesson 9.6, and be sure and include today's date, okay? Solving Right Triangles, Lesson 9.6, and be sure and include today's date, alright? Okay, here we go. First, let me explain what solving a right triangle means. It means that you find the measure of all missing angle and side measurements. Let me say that again. It'd be a really good sentence to write in your notes. When I say solve a right triangle, I want you to find the measure of all missing angle and side measurements. That's what we're doing when we're solving a right triangle. So, if you were given the triangle below, you would need to do what? Well, let's see. I'm missing this length here and this length here. I'm missing this side and this side. So if you were given the triangle below, you would need to find the lengths of AC and BC, right? Because this length here is missing, question mark, and this length here is missing. What else would you need to find? The measure of angle A. It's missing. That is what you would need to do in order to solve the right triangle. Do you see what I'm saying, students? So when I ask you to solve a right triangle, you look at the triangle that's given to you and you find all of the missing angles or sides, and then you have solved the right triangle once you've done that, okay? Alright, now you can solve a right triangle. This is a really important sentence. I would also write this in your notes if I were you. You can solve a right triangle as long as you know two parts. Now when I say two parts, that's not including the right angle. We know we're always going to have a right angle. That's just understood to be given to you, okay? Do you understand that? So, you can solve a right triangle as long as you know two parts. As long as at least one of these parts is a side. Okay, so when you go to solve a right triangle, you have to know at least two other parts besides the right angle, okay? And one of those, at least one of those parts has to be a side. Now, if I give you two sides, like 7 and 9, and there's no angles, you can definitely solve that right triangle because you've been given two parts, and at least one of those parts is a side, okay? You can solve this triangle here because you have two parts that you know, and at least one of those parts is a side. Okay, let me say it again. You can solve a right triangle as long as you know two parts. That's not including the right angle. As long as at least one of these two parts is a side. Now let's move on. Before we start solving right triangles, there's something I need to teach you how to do first, okay? You need to know how to find missing angles by using trig functions and a calculator. If you can't do this, then you can't solve right triangles, okay? So before we get into solving right triangles, I need to teach you how to find missing angles using your calculator and trig functions. Very, very important, okay? So here we go. Please take really good notes. Alright, copy these two examples in your notes, please, if you would, okay? Copy these down. Sine of 35 degrees equals x, and sine of x equals 0.8269. Now, notice one of these is missing the ratio, and one of these is missing the angle. Let me show you what I mean. This one here is not missing the angle because we have 35 degrees. You're missing the trig ratio right here. Okay? Do you see that? Sine of an angle. Over here, notice that you're missing an angle. Okay? You're missing an angle. I hope you see the difference, guys. One of these, you're not missing an angle. You're missing the trig ratio over here, or the decimal, whatever you want to call it. And over here, you're missing the angle, okay? And you're given the trig ratio or a decimal, whatever you want to call it. So, students, do you see the difference between these two? use your calculator to solve both of these, but they are done completely different, okay? You need to understand that they are done entirely differently. So, having said that, this one here has an angle, and you're missing the ratio. This one here does not have an angle, and this one here has the angle, and you're missing the ratio. This one here, you're missing the angle, and it does have the ratio. Okay? Now this one here, we learned how to do yesterday. So let's practice it again, okay? Make sure your calculator's in degrees, alright? And then go ahead and hit sine. And then 35 degrees, alright? Now make sure your calculator's in degrees. It's very important, alright? Sine of 35 is 0.5736. Now that's pretty simple. We learned how to do that yesterday. But students, what about when you're missing the angle and you're given the trig ratio or the trig decimal? How are you going to find that missing angle? Well, there's a button on your calculator, and students, I wish I was there. You're going to have to find it on your own, okay? It's a button that looks like this. And some of you, you might have to pause the video, guys, and help each other find it. Okay? It's a sine to the negative 1. That's called inverse sine, or sine inverse. Now, usually, you'll find that right above the sine button. For example, on a graphing calculator, a grapher, here's your sine button right here, and it says S-I-N. Well, right above it, in yellow, you're going to see sine to the negative 1. So you have to hit the shift button or the yellow second button. Now yours might not be yellow, it might be a different color, but hit the second button, then hit this, and up will pop on your screen sine to the negative 1, or inverse sine. Do you see that okay? Now the rest of you that don't have a grapher, you're going to have to find that sine to the negative 1 somewhere on your calculator, okay? So pause the video if you need to. Help each other. Let's find these, then we'll move on, okay? I'm going to go ahead and go on. Pause the video if you need to. But here's what I want to drill into your head. If you miss anything today, don't miss this. Guys, the only time you use this inverse sine button or inverse cosine button or inverse tangent button, the only time you use that button is when you're missing an angle. Don't use it any other time, okay? Please don't do that. You're going to get confused if you don't listen. Only use inverse sine or inverse cosine or inverse tangent when you're missing the angle. Were we missing the angle over here? No. So did we use sine to the negative 1? No. We just used our sine button. Okay, so type this into your calculator and then hit 0.8269. Now some of your calculators might want you to first type in 0.8269 and then inverse sine. But either way, you figure that out. You're going to hit enter, okay? And when you hit enter, you're going to get 55.78159757. So I'm going to say, I'm going to round it to the nearest degree, 56 degrees. So now you know the sine of 56 degrees is 0.8269, approximately. Okay, guys, let's go over this again. Whenever you're not missing an angle, you just use the regular sine button or cosine or tangent. Whenever you're using the inverse button, whenever you're missing the angle, you use the inverse sine or inverse cosine or inverse tangent, okay? Now that's pretty much an explanation, but now we need to do the wonderful word called practice, okay? So let's practice this. Here we go. Let's quickly practice a bunch of these. Copy this in your notes, please. And let's see if we can't solve this, okay? The sine of 82 degrees. Now, I have one question for you, students. Are you missing the angle? Well, no, it's right here, 82 degrees. So since you're not missing the angle, we're going to use our regular sine button. So go ahead and push sine. Make sure you're in degrees. And then push 82 degrees, okay? And the sine of 82 degrees is 0.9902680687. I'm going to put 0.9903. I'm going to round it to 4 decimal places. 0.9903, okay? is right here 22 degrees. So I am not missing the angle, okay? So cosine of 22 degrees, since I'm not missing the angle, I'm going to use my regular cosine button. Cosine of 22 degrees equals, okay, go ahead and hit cosine 22, enter, and you're going to get 0.9271838546. I'm going to round it to 0.9272. Alright, that's where I'm going to round it to. Cosine of 22 degrees. So far, pretty easy. If you're not missing the angle, you just hit the trig function button and the angle, hit enter, and you'll get out the ratio. Okay? Or the decimal. Alright, let's take a look at this one. Now this one's different. I have one question for you. Are you missing the angle right here? The angle that you're taking the tangent of? Yes, you are. So if you're missing the angle, then that's when you use the inverse button. So hit tangent inverse, and this should pop up on the screen. And then you type in 7 divided by 4. Alright? I would put parentheses around it if I were you, if you're able to. 7 divided by 4. Now, if you're having a hard time entering that into your calculator, no problem. Then just change this to a decimal. Instead of using 7/4, use 1.75. Isn't that okay to do? Sure it is. So now you would hit inverse tangent, and then hit 1.75, okay? This will work, or this will work. They're the same thing, okay? Hit enter, and here's what you're going to get. 60.2551187. So it equals approximately 60 degrees. So there you go, your answer is 60 degrees. So you found the angle, okay? So when you take the tangent of 60, you get approximately 1.75, okay? So we were missing an angle. We used the inverse tangent, okay? Let's try another one. Please copy this in your notes. Tangent of 50. On all of these, you are more than welcome to work ahead or stay with me. It's totally up to you. Okay, we're going to find the tangent of 50. Now, am I missing the angle? No, I'm taking the tangent of 50 degrees. So we're not going to use the inverse tangent. We're just going to hit tangent and then 50 degrees. Alright, unless your calculator is different, and you hit 50 degrees first and then tangent. Okay, either way, depending on your calculator, here's what you should get. The tangent of 50 is 1.191753,593. So I'm going to round that to 1918. 1.1918. There we go, students. There it is. Pretty simple. Let's try another one. Okay, cosine of x equals 0.5. Now, students, one question for you. Am I missing the angle? Well, in this case, I am. The angle that I'm taking the cosine of is missing right here. So whenever you're missing the angle, that's when you use your inverse button. So go ahead and hit cosine inverse. And then type in 0.5. Okay, inverse cosine. And then 0.5. And the angle is going to be 60 degrees. So that means the cosine of what? 60 equals what? 0.5. Okay, so you found the angle. Alright, let's continue on. Last one. I have one question for you. Am I missing an angle, or am I not missing an angle? Yes, I'm missing an angle right here, the sine of some angle. So I'm going to use my inverse sine button. So I'm going to type sine, inverse sine, and then 0.8215. Now I've not typed that in yet to my calculator, so let me do that quickly. Second sine, 0.8215. And enter. I'm getting 55.23523262. So 55 degrees. Okay. And students, there we go. Alright. So what I want you to take from this before we start solving right triangles is simply this. You must need to look at problems like this and realize when you're missing an angle and when you're not missing an angle. And if you're not missing an angle, then you do not use the inverse buttons. But if you are missing an angle, then that's when you use sine inverse or inverse cosine or inverse tangent. Okay? Alright, let's continue on. Now, I hope that you guys feel confident in using your calculator with these types of problems. So let's start solving right triangles, alright? So please copy this in your notes, and let's take really good notes. Here we go. Here's the first problem. We're going to solve right triangles. So copy this right triangle in your notes. Copy this right triangle in your notes. Okay, students, here we go. Now, I'd like to show you that we know two sides, don't we? Let me put it to you this way. Always solve for the easy stuff first. For example, if I knew this angle right here was 30 degrees, could I not find this angle over here like in 5 seconds? Because we know 30 plus 90 plus this angle here has to add up to what? 180. So we can find that missing angle pretty quickly. Well, it's the same thing with the sides. If I know two sides, why not quickly use Pythagorean Theorem and find the missing side first? So here we go. I'm going to use Pythagorean Theorem. Take some good notes on this. 4 squared, leg squared plus leg squared equals hypotenuse squared. That would be 16 plus 25 equals c squared. Add them together, we get 41 equals c squared. Now take the square root of both sides. So c equals square root of 41, okay? So, do I know the lengths of all three sides now? Yes, I do, definitely. Now we've got to find the angles. Now here's where it gets really, really tricky. So please, please, please listen carefully. What angle do you want to solve for first? You can solve for A or B, it does not matter. So I'm going to choose one, and we're all going to solve for the same angle. But remember, it doesn't matter, so you really can solve for any angle you want to first. I'm going to start with the angle A, alright? Now, if I'm going to start with angle A, please listen to me. That makes 5 over here your what side, remember? Opposite. This side here is still your what? Hypotenuse. And this side over here is your adjacent side. Got it? Now, please watch this carefully, students. I'm going to use either sine, cosine, or tangent to find this missing angle. We're going to call it angle A. Now, I really don't care which one you use. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Please listen to me, students. You can use any of those. I don't care. But here's the catch. I have a strong suggestion to make to you. Why in the world would you want to try to solve for an angle using a really nasty number like that, square root of 41? That's going to be a pain in the neck. Okay? So, I'm going to try to use a formula over here that doesn't have hypotenuse in it, because I don't want to have to use that number in my formula. Now, if you feel differently and you want to use sine, even though it has hypotenuse, or cosine, even though it has hypotenuse, please feel free to, and you'll still get it right. Just a little more of a pain in the neck, okay? I'm going to use tangent. Now remember, once again, you can use any of these trig functions you want to. I'm choosing tangent. So tangent of what angle? Well, I just told you. What angle are we solving for? A. We chose that. Could we have solved for B first? Most definitely. Doesn't matter. Tangent of A. Now what does tangent of A equal? Well, it equals opposite over adjacent. So my opposite is 5, and my adjacent is 4. Now let that sink in, okay? Look that over carefully. We knew we were missing an angle, okay? So I said tangent of angle A equals, and then what does tangent of an angle equal? Opposite over adjacent, so 5 over 4. So now I can find this angle. Remember, I'm missing an angle, correct? So what button do I use on my calculator when I'm missing an angle? Inverse tangent. So you would type in inverse tangent. And then type in 1.25, because 5/4, if you take 5 divided by 4 in your calculator, you will get 1.25. My pen's really messing up here. There we go. Alright, so inverse tangent 1.25 51.34 degrees. I'm going to round it to the nearest whole number to make it easier. So angle A is 51 degrees. There you go. Look at that. Isn't it cool how we can use trig ratios to find an angle? Now, to find this angle is so easy because we know that 51 plus 90, 51 plus 90 plus angle B has to equal 180. So that makes this angle here 39 degrees because 51 plus 39 is 90 and 90 plus 90 is 180. So do I know the measurement of all three angles? Yes. Do I know the measurement of all three sides? Yes. Did I just solve this right triangle? Yes, we did. Alright, let's try a couple more of these. Copy this in your notes, please. Copy this down. Take a second and copy this down, please. Okay, students, now listen carefully. Like I said in the last problem, if you know the lengths of two sides, find the third side first. Do it quickly using Pythagorean Theorem. But in this case, we know the measurement of two angles, not two sides. We know one angle is 90, and we know the other angle is 35 degrees. So can I not very quickly find this other angle over here? Sure I can. It has to be 55 degrees because 55 plus 35 is 90, and 90 plus 90 is 180. So just like that, I found the measure of angle B. Now, I have to find this angle, this side here. I'm going to call it side little b, because it's across from B. And I'm going to call this side here little a, because it's across from A. I have to find the measurement of this side and the measurement of this side. Now, how in the world are we going to do that? Well, here's how we're going to do it. So please, students, take some really good notes. Are you ready? We're going to pick an angle, not 90, of course, never 90. We're going to pick an angle. It does not matter which angle you pick. Just like over here, when we had to pick an angle to solve for first, it did not matter. If you pick, sorry for yawning, if you picked angle A first or angle B first, it didn't matter. Same thing here. Pick any of these two acute angles you want to. I'm going to pick this one because I feel like it, okay? So if that's the angle I'm picking, go straight across. This becomes my what side over here? Opposite. This becomes my hypotenuse. And so this third side over here is my adjacent side. Now, watch this carefully. We're going to use our trig functions to solve for A and B. So we know sine equals SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Now, guys, I need you to use common sense. There's only so much I can teach you, but part of it has to be you using good reasoning skills, okay? Why in the world would you want to use a function here that has adjacent and opposite like this one here? Isn't that two unknowns? You would have two unknowns in one problem. You don't know the length of B, and you don't know the length of A. There's no way you want to use both of those sides in one equation. That doesn't make any sense. Use common sense. You want to use one of the trig functions that has one of your known sides. Now, which side do I know the length of? Hypotenuse. So use sine or use cosine. It doesn't matter which one. To find the length of the other missing side. Okay? It doesn't matter which one you use, but use one of them. Okay? Why would I use one of these? Because they both have hypotenuse in them. And what's the one side that I know? The hypotenuse. See how I'm kind of using common sense here? Alright? So it doesn't matter which one you use. I'm going to use sine. Doesn't really matter. I'm just choosing that one. So, sine of, let's see, sine of, now what angle did I pick for this problem? 35. So sine of 35 degrees equals opposite over hypotenuse. So opposite is side A right here. Hypotenuse is 8. Now let's solve for A. We actually learned how to do this the other day in a video. Remember, first of all, sine of 35 is just a decimal number. Don't forget that. So sine of 35 is 0.5735764. So I'm going to put 0.5736. And my pen is really messing up, guys. Sorry. 0.5736 equals A over 8. Now next, students, I'm going to get rid of my fraction. Remember, whatever the denominator is, in this case it's 8, you multiply both sides by 8. So I'm going to take 0.5736, I'm going to multiply it by 8, and I'm going to get 4.5886. And if you multiply this side by 8, like 8 over 1, your 8's will cancel, leaving you with A. So I found the length of A. A is 4.6, okay? Everybody with me? Now, watch what I do next. Yes or no? Do I know two sides of the triangle? Of course I do. I know the hypotenuse, and I know one of my legs. So let's use Pythagorean Theorem to finish it. Let's use Pythagorean Theorem. One of my legs is B, from right here. My other leg is 4.6. And my hypotenuse is 8. Now, if you square 8, you'll get 64. If you square 4.6, you're going to get 21.16. Just use a calculator, okay? Now bring the 21.16 over and make it negative. And so cross it off, bring it over, make it a negative 21.16. And you're going to get 42.84. And that's what B squared equals. Now take the square root of both sides. The square root of B squared is B, and the square root of 42.84 would be 6.545227.269. So 6.5 sounds acceptable. 6.5. So B is 6.5. There we go, students. Okay? So we've solved two right triangles so far, okay? Not too bad. They're not super easy, but they're challenging. You gotta really think, okay? Now I'm gonna throw a little curveball at you guys and see how you do on this one, okay? Here we go. Copy this in your notes, please. I'm giving you a right triangle, and all that you know, students, is simply one side, nothing else, just one side. AC is 10. Okay, you know nothing else about this triangle, except you do know that the tangent of angle A is 1. So that's going to help a little bit. So copy this down, then we'll talk about it, okay? Copy this down, then we'll talk about it. Okay, here we go. Now, students, do we know two sides? No, we don't. I wish if we did, we could use Pythagorean Theorem. Do I know two angles? No, we don't. I wish I did. Because if I did, I could then just add the two angles together, subtract from 180, and I would know the third angle. Okay? However, I don't have that. But here's what I have over here. Notice they tell me the tangent of angle A is 1. Okay? Tangent of angle A is 1. So I'm saying to myself, okay, let's think this through for a second. Using my calculator, I just learned earlier during this video how to find that missing angle. So if I can find that missing angle, then I'll know the angle of angle A. Then I can quickly finish the triangle. So I'm looking for an angle, correct? Tangent of angle A. So with your calculator, because you're missing an angle, you're going to hit tangent inverse of 1 and hit enter, and out is going to pop on your screen 45 degrees. So now I know the measure of angle A is 45 degrees. That's a big help. Now I know that B has to be what? 45 degrees, because 45 plus 45 is 90, plus 90 is 180, okay? Now we got to find our two missing sides, okay? We have two missing sides. Now students, listen to me. Just like in the last problem, we were missing two sides. You had to pick an angle. It did not matter it did not matter which angle you picked, okay? You must pick one of your angles. One of your angles. Well, I'm going to pick angle B just because I feel like it, okay? So if I'm dealing with that angle there, go straight across. This is your what side? Opposite. This is your what side? Hypotenuse. And this is your what side over here? Adjacent, okay? Now, like I told you again, during the other problem we were solving, guys, look. You have sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent, SOHCAHTOA. Okay? Now look, guys. What are your two sides you don't know the lengths of? Hypotenuse and adjacent. So use common sense. Why in the world would you pick a trig function that has hypotenuse and adjacent like cosine? That's not going to be any good. That's going to hurt you, guys. That's going to hurt you because you're going to have two unknowns in the ratio right here. You don't know what the adjacent side is, how long it is, and you don't know how long the hypotenuse is either. Okay? So don't use that trig ratio. Listen, what side do you know the length of? Opposite. So use one that has opposite. You can use this one or this one. I'm going to use tangent just because I feel like it, no other reason, okay? So I'm going to say the tangent of, now hold it, what angle did I circle? 45 degrees. So the tangent of 45 degrees equals opposite over adjacent. So my opposite side is 10. My adjacent side is, well, this is a big capital A over here, so let's call this side A. Here's a capital C here. Let's call this over here side C. Okay? So tangent is what? Opposite over adjacent. Here's my opposite. Adjacent would be A. And now remember, tangent of 45 is just a number, okay? Don't forget that. So, tangent of 45 is going to be 1 actually. So, I'm going to put 1 for tangent of 45 equals 10 over A. Now, what is my denominator? A. Multiply both sides by A to get rid of your fraction. So 1 times A is just A. And 10 over A times A. 10 over A times A over 1. Your A's would cancel, leaving you with 10. So now we know the length of A is going to be 10. Okay? Now, students, I can use Pythagorean Theorem to find the last missing side, because one leg is 10 and the other leg is 10. So one leg is 10 plus the other leg is 10 equals the hypotenuse, which is C squared. Well, this is 100 plus 100 would be 200 equals C squared. And now let's take the square root of 200, and we're going to get approximately 14.1421. I'm just going to put 14. So this side right here has a length of 14. Okay? So there we go, guys. We solved another triangle, another right triangle. Okay? Listen, if you know two angles, the first thing you do is find the third angle. If you know two sides, the first thing you do is you find the third side using Pythagorean Theorem. And then from there, you're going to use your trig ratios to find other missing sides or other missing angles. Okay? Now, let's apply this new acquired knowledge to a wonderful, exciting, awesome word problem. Okay? So I would encourage you to turn in your books to page 463, example number 2. Okay? I would encourage you to turn in your books to page 463, example number 2. I'll pause a second while you're doing that. 463, example number 2. Now the problem reads something like this. Any electronic distance measurement instrument measures distances by recording the time required for a signal to reflect off an object. You are surveying a portion of Spider Rock. You are using an EDM instrument and a theodolite. I'm not sure what that is, to be honest with you guys, which measures angles. Your measurements are shown in the diagram below. How much taller is the left column of Spider Rock than the right column? Okay, so here we go. Now if you look in your book, you have a triangle that kind of looks like this. You have, the drawing looks something like this. And then a triangle going a little higher, then a triangle going a little lower, like this. And I'm drawing this down like this. And then this one here, straight down over here like that, okay? And they have this angle here is 54 degrees. And this whole angle is 58 degrees. Now that's how they have it kind of drawn in the book, but I thought it'd be better if I split those two triangles up, okay? So, I'm going to split the two triangles up, and they'll look like this. Okay, let's go back a page again. So right now they're kind of on top of each other, but if I took this triangle here, and pulled it off to the side, and then took this triangle here, and pulled it over here, then I would have my two triangles. Now I know they don't look like right triangles perfectly, and my drawing isn't perfect, but I hope you're getting the idea, okay? We're going to pull these two triangles apart and separate them. It'll make the problem a lot easier. Now, what they're asking us to do is this. Watch carefully. If this triangle fell right on top of this triangle like this, they're asking us to find this distance right here. How much taller this side here is than this side here. So they're wanting us to find this little extra distance right there, okay? Now, doesn't it make sense, guys, that I would first find this side here? I'm going to call this X, alright? Then I would find this side over here, Y, and then do what? Let's just pretend. Now, this isn't right, but let's pretend this whole side here is 20. Let's pretend this whole side over here is 17. How would I find this little bit of extra space right here? I would just take 20 minus 17, and I would know this little length right here is 3. So guys, we're going to do the exact same thing. We're going to find the length of this side here. Then we're going to find the length of this side here. And then we're going to subtract the two. It's really pretty simple. So here we go. Now, you say, Mr. Earhart, how can we find this side? We only know one side. We're going to have to use a trig ratio, sine, cosine, or tangent. Now, what angle are we going to use? Well, we really only know one angle. So we're going to use this angle here. So this side over here is called my what? Opposite. This side over here is called my what? Hypotenuse. Alright? Now I really don't need this side here because this is the side I'm looking for. And this is the side that I know. So do you see what I'm saying? There's no need to bring this side into the picture, okay? This is just another unknown, another length of a side that I don't know the length of. So students, having said that, I'm dealing with two sides. Opposite. Why opposite? Because that's the side I'm looking for. Hypotenuse. Why hypotenuse? Because that's one of the sides I know. I need one side I don't know and one side that I do know. So, with this in mind, here are my trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So I have a question for you. If I'm going to use hypotenuse and opposite, which one of these trig ratios has opposite and hypotenuse? Both. Just one of them does. This one here. So I know I'm going to use sine. So I'm going to say the sine of what? 58 degrees equals opposite over hypotenuse. Opposite is x. Hypotenuse is 944. Now remember, the sine of 58 is just a number, okay? It's nothing more than a number. So sine of 58 is 0.8480480962. So the sine of 58 is 0.8480 equals x over 944. Now multiply both sides. Your denominator here is 944, okay? So after I took this and converted it over to my decimal number, then next I'm going to multiply both sides by 944 to get rid of my fraction. So if I take 0.8480 times 944, I'm going to get 800.557. So I'm going to put 800.6 equals x. So this whole length from here all the way down to here is 800.6, okay? Okay, now students, look at this triangle over here, okay? I've got to find this length here. What angle am I going to use? Well, guys, it ends up being the exact same thing as this. What angle am I going to use? Well, I only know one angle. So this over here becomes my opposite side. This is my hypotenuse side. There's really no need to worry about the other side because look, this is the side I'm looking for, so I have to use opposite. Hypotenuse is one of the sides that I know the length of, so I'm going to use hypotenuse. So I'm looking for a trig ratio that has opposite and hypotenuse. Sine does. So sine of what angle? 54 degrees equals opposite over hypotenuse. Okay, so opposite over 855. Now remember, sine of 54 is a number, so sine of 54 equals 0.809016994. I'm going to put 0.8090, so 0.8090 equals y over 855. Now, remember, next, whatever your denominator is, in this case it's 855. In this case it's 855. You're going to multiply both sides by 855, okay? So if you multiply 0.8090 times 855, you're going to get 691.709532. I'm going to put 692. Now again, you can round to different places, that's okay. Now if you multiply the right side by 885, you're going to get y. So this side here is 692. Okay, students, so how do you find this little extra space right here? Watch carefully. How do I find this little extra distance right here? The distance from here to here. Well, hopefully it's common sense, I hope. You're going to take this whole length here, which is 800.6, and you're going to subtract from it this length here, 692. Okay, so here we go. If you do that quickly, you're going to get 108.6. Okay, I think the book had 109, which is just the difference in where you rounded. Okay, so there we go. Guys, I told you at the start of the class period, at the start of the videos, when we get into trigonometry, it's not going to be super easy stuff. So you got to be ready for that. You got to understand that, and you got to really take good notes, pay attention, and be ready to work extra time on your homework problems, okay? Alright, I hope this video has been a help to you. If you have any questions, don't hesitate to call or email.